Hello students, welcome in the series of lectures on multiple integral. In this lecture, we are going to discuss another important concept of multiple integral, that is change of variable. Means today we are going to discuss that how one can change the variable of integration in a multiple integral, that is in double integral. So this concept is not new for you. I think already you have done single integral or integral with one variable. There you also done the thing which is known as change of variable. Means what? I am giving you an example. If you remember, you have done method of substitution. Method of substitution means what? Suppose that I am having integral, let it be 0 to 1 y square e to the power minus y cube into dy. Suppose that I am having an integral in terms of y, that is variable y. So in order to solve this integral, I can do the method of substitution. That is also known as change of variable. Change of variable in double integral means if I do substitution, that what? That let y cube is equals to t. Then what I will get? I will get 3y square into dy is equals to dt, and do the substitution over here. Then what I will get? It will be y square into dy will be dt over 3. So 1 upon 3 can be taken outside, and this will be e power minus t into dt. Now you can see the integral which seems to be complicated one at an initial level. After changing its variable, the variable, after changing its variable to another set, it look like easier one, e to the power minus t into dt. Moreover, the limit of integral will also change. When I put 0 in place of y, the limit of t will be 0, and 1, the limit of t will be 1. It is the change of variable concept in the case of the single integral, that is the case of one variable. Now it means what? We have changed dy by what? Dt. Dy by dt. Not only dy is changed by dt, but also you can see that dy is changed with something else. That is, if I am writing in terms of purely in terms of t, so dy will be what? Dt upon, from here the value of y will be t to the power 1 upon 3. So this will be 1 upon 3 into t power 2 upon 3. That is, dy is going to be changed with dt over 3 into t to the power 2 upon 3. This is the case of change of variable in the case of one variable, or we can say in the case of simple integral or single integral. The meaning of this is what? In original, this is what in one dimensional, that is on y axis, we are having from 0 to 1. This y axis is going to change in another t axis. Means change of variable means what? Y axis I have just changed in t axis. Coincidentally, the limit is same. Means change of variable means in single integral that we are changing the axis. The changing the axis, it may be sync or it may be like extended. It may be sync or extended according to the substitution that we have done. Now, if I am talking about change of variable in double integral, like I am talking about double integral over R function of x comma y dx dy. It means what? I am solving this integral over a region R. Over a region R. And if I do the substitution in this integral, now here we have to do two substitution, one for x, another for y. Then this integral will go on change. Means if I am doing the substitution, let x equals to a function of ub and y is equals to function of ub. That is, I'm going to change the integral from xy to ub. Then this integral will look like what? Double integral function of phi of ub, comma, psi, or let it be phi 1, phi 2, that will be better. Phi 1 of ub, phi 2 of ub into, I'm just leaving some space blank, du dv over r dash. Now, what the change you just as seeing, that the region which is initially r in xy plane will change into r dash in uv plane. Means it is a kind of substitution that I did for x and y for changing the variable. Now f is converted into function of ub by this substitution. R is converted into new region r dash, and dx dy, what is dx dy basically? It is also known as dA, the area, is changes by what? Du dv into what? If you remember previously, dy is changed by dt into something. So same, that is dy is changed by the derivative of the substitution. Dy is changed by the derivative of the substitution, or we can say rate of change of that variable. Here, the same thing can be done. That is, r is changes into r dash on a thing which is known as a Jacobian. This is what? Known as Jacobian. So in another word, it's not as simple as it look like, that xy is converted into ub, but also we are having a factor which is known as Jacobian, which come inside the integral when the region is converted from r to r dash. When a region is converted from r to r dash, it means what? Jacobian is evaluated or obtained from the given substitution. The substitution that we have did, on the basis of that, this j will be calculated. J is what? Nothing but Jacobian, which is what? The rate of change in x and y. The rate of change in x and y with respect to u and v. If you remember, in single integral, when we are changing the variable like x into t, we have replaced dx by what? Dt, or with some term. That is rate of change in x with respect to t we are doing. But here the substitution is what? X to u and x to b. That is, we need to calculate two rate of change. The same for y to u and y to b. So the same we have to do for variable y. It means what? We need to just find the rate of change in x with respect to uv and in y with respect to uv, which is nothing but same as the Jacobian. This is what, students, the simultaneous rate of change in xy with respect to uv. This is the quantity which comes when we are changing the variable from xy to another set of variable in double integral. Obviously, we are changing the area, but when we are changing the area, that the variable, that scale is changing. The scale is changing, or we can say there is a local change in the existing variable xy with respect to the new variable uv, which can be given by del of xy upon del of ub, and this quantity is denoted by j, which is known as Jacobian, and it is defined as nothing but a 2 by 2 determinant, that is change in x with respect to u, that is partial derivative of x with u, the same for x for v, the same y for u, and the same y for b. That is all the rate of change comes over here. This is what the Jacobian. Remember, in the integral, we have to take its magnitude. We have to take its magnitude, a positive quantity. So this is how we can do the change of variable in double integral. That is, we are changing the, not only changing the variable, but also changing the region of integral. the region of the integration from xy plane to uv plane. That's why this Jacobian is coming in the integral. So another time I'm replacing. So double integral r f of xy dx dy will be replaced by what? R dash f. I'm replacing x and y with the substitution that we have did, that is this term, into Jacobian into du dv. This concept is known as change of variable, students, in multiple integral. In the same manner, when we are changing variable in the triple integral, it means we are changing the volume from xyz plane to some another plane. It may be spherical or cylindrical or something else. Here we are doing the, in one dimensional integral, we are just changing the axis from x axis to some another axis. In double integral, we are changing the region of integral. Means suppose that in xy plane a region is like a circle, and when it is converted into uv plane, it may become a rectangle or a ellipse or a rhombus or something else, according to the substitution that we are doing. And this will be the r dash. This will be the r dash du db, because we are doing substitution Jacobian. This is why when we are changing the variable, the quantity Jacobian is come, because it covers the rate of change. Because we need, in case of one variable, if you see the previous slide, we need to replace dy by dt na, dt upon what? This quantity. This is the rate of change. This is the change that we are having. It's not only we are just changing dy by dt, no. In the same manner, it's not dx dy will change by du dv. It will change, but also we are having, we just do the scaling, or we can say local change in area, which can be represented or calculated by Jacobian, and this is what Jacobian is. And this is why Jacobian comes when we are changing the variable of integration. I hope you understood the concept. In the same time, when we are changing an integral into polar coordinate, in the same time, now what is the goal of changing the variable? Same as the previous one. You can see, to solve the original integral over here, it's little bit challenging. So why I'm changing the variable? To reduce its complexity. You can see the complexity of the question now will decrease. It's too easy to solve this integral in comparison to the given integral. So the same thing we are doing over here when we are changing the variable. When we are changing the variable, we are trying to reduce the complexity of the given integral. In case of polar coordinate, in case of polar coordinate, if I am talking, means if I want to change a double integral from xy plane, that is Cartesian coordinate, to polar coordinate, what should I do? The substitution is x equals to r cos theta and y is equals to r sin theta. X equals to r cos theta and y equals to r sin theta. If I do the substitution, the Cartesian coordinate is converted into polar coordinate, where r is known as the radius vector, and theta is known as the vectorial angle. Vectorial angle, radius vector. Now the thing is comes, what should I replace for dx dy? If you remember, it's simply dr d theta into Jacobian will come over here. Dx dy into Jacobian with dr d theta. So what should be the Jacobian in this case? It will be Jacobian of xy, that is the partial derivative of xy with respect to r and theta. Simply, it is a 2 by 2 determinant. So del x over del r, del x over del theta, del y over del r, and del y over del theta. Put these value over here. The partial derivative of x with respect to r, that is cos theta constant. So 1 into cos theta. Now x to r is done, x to theta. So r is constant and cos theta derivative is how or what? Minus of sine theta. Now y to r, so 1 into sine theta. In the same manner, del y over del theta will be del y over del theta. So r as it is, sine theta will be what? Cos theta. Simplify. So it will be r cos square theta plus r sine square theta. R can be taken outside. What left? Cos square theta plus sine square theta. And the value of cos square plus sine square is 1. That is r equals to 1. It means, students, when we are replacing a double integral from Cartesian coordinate to polar coordinate, we should replace dx dy by what? Jacobian dr d theta. That is r dr d theta. Let us take a question that how we can change an integral into polar coordinate. The question I am taking is what? Change the integral, which is what? 0 to a and 0 to root over a square minus y square. A square minus y square. Inside we are having y square root of x square plus y square into dx dy. Change into polar coordinate. Change it into polar coordinate. Means we want to change the variable from xy to r theta. In the previous slide, we just find that Jacobian in the case of polar coordinate is r. So there is no need to once again calculate it. Directly we should use the value of Jacobian over here. I am just changing it. It will be what, students? R dash. Reason is r dash. Originally reason is what? Which is formulated from these reasons, these limits. Y, we are having r sine theta. So this will be what? R square sine square theta root over x square, that is r square cos square theta plus y, that is r square sine square theta into Jacobian into dr d theta, which will be equals to double integral over r dash sine square plus cos square 1, that is root of r square, which is r, and r into r square will be r power 3. Jacobian is also r. So total will be r to the power 4 into sine square theta into dr d theta. Means the original integral which look like this, when converted into polar coordinate, it will look like this. Now another thing, variable is changed, but still we need to find the reason of integration in order to get the limits for the new integral which is in r and theta plane. So let us decide the reason of integration also. As you see that the given limits, it's given that if I am writing the given limits, we can draw the reason with the help of the given limit. This we have already learned in the previous lectures. This limit in terms of y. So this is the limit of x, that is x equals to 0 to x equals to root of a square minus y square, which will be what? X square plus y square equal to a square. Means I just squaring on both the sides and I find this is the equation of circle. Now the limit of y will be given as y equals to 0 to y equals to a. Now with the help of this reason, I need to draw a reason in polar coordinate. Let us see how it will look like. From the given limit, what I am getting? X equal to 0 to x square plus y square equals to a square. And the limit of y will be y equals to 0 to y equal to a. This is the given information. Let us try to draw it. So first of all, a circle. I just draw a circle in xy plane whose radius is a. That is, this point is a comma 0. X equal to 0 is lying on y axis. That is, this line is x equal to 0. Y equal to 0 is this line, and y equal to a is this line. So moreover, students, it's not the whole circle. What the reason? It's only 1/4 of the required, 1/4 of the whole circle. How I decide it is 1/4? You can see on the basis of the limits, I just decided it. So this is what, students, we are having. This is what? R dash. This is not R dash, this is R. This is the given region in XY plane. This is R. Now I need to draw R dash. Let us see how. I just convert this circle into x equals to r cos theta, y equals to r cos theta, x equals to r cos theta, and y is equals to r sin theta. I will get r equals to a, which is the equation of circle in polar coordinate. So once again, r equals to a, this equation, r theta plane. Moreover, x equals to 0 means what? X equals to 0 means what? R cos theta equals to 0. R cos theta equals to 0 means what? Theta equals to pi by 2. So this is the line which we are having. Theta is pi by 2. Y equal to 0 means R sin theta equal to 0. That is sin theta equal to 0. So theta equal to 0. This is the line theta equal to 0. So now we can see what is the required region. Once again, this is the required region in r theta plane. This is the required region in r theta plane. Now, region is identified. So what the next we should do? We have to find the limit of integration by taking the strip. If you remember, we have discussed that in polar coordinate, the elementary region is taken inside along the radius vector. So what is the value of r on the center? It's always 0 on the center of a circle. And at the circumference, it's r equals to a. So what will be the new limit, students? R is from 0 to a. That is the variation of r. Now, if you see theta, for this reason, the variation of theta is how much? It started from x-axis up to over here. This is the variation of theta counted from the positive x-axis in anti-clockwise direction, the theta. This line is theta is 0. This line is theta is pi by 2. So limit of theta will be 0 to pi by 2. Now finally, limit is obtained from the region. So hence the given integral, which is given as what? 0 to a and 0 to root of a square minus y square into y square of x square plus y square dx dy, which seems to be too much complicated to solve in Cartesian coordinate. When converted in polar coordinate will be r equals to 0 to a and theta equals to 0 to pi by 2. What we are having inside? It is r power 4 into sine square theta dr d theta. We can cross check it whether we are right. Yeah, r4 sine square theta. So now this is the change of variable that we are having. XY coordinate to r theta coordinate, and this is the new limit. Now I think you can see it's a too easy to solve it. Firstly, the integration with respect to r. So r power 5 upon 5. It will be 0 to pi by 2. R to the power 5 upon 5, 0 to a into what? Sine square theta. D theta, put the limit, upper limit minus lower limit. So it will be a power 5 upon 5 minus 0. Taken outside, 0 to pi by 2 sine square theta. Just reduce sine square theta by using cos 2a formula. We are having cos 2a formula, na? What is cos 2a we are having? That cos of 2 theta is cos square theta minus sine square theta, which is 1 minus 2 sine square theta. That is, from here, we can say that sine square theta is what? 1 minus cos 2 theta upon 2. Put it over here. So 1 upon 2 I am taking outside, so it will be 10. 0 to pi by 2, 1 minus cos of 2 theta into d theta, which is equals to what? A power 5 upon 5. One integration is theta, cos 2 theta integration, sine 2 theta upon 2, limit is 0 to pi by 2. If I put upper limit in sine 2 theta, this will be sine pi, and sine pi is 0. When I put 0, sine 0 is also 0. So finally, a power 5 into pi by 2, because the rest of the term will be 0. So pi into a power 5 upon 10 is the required answer for this double integral by changing it into polar coordinate. So this is how we can change a double integral to a polar integral. Polar coordinates, double integral in Cartesian coordinate to a double integration in polar coordinate. Now, how the question may be asked? They may ask what may be the limit of the transformation, means after converting the integral, how the integral will look like, or they may ask what will be the value of the integral. Yes, so this is how, students, we can convert xy to polar coordinate. Let us take an example in which we need to convert a region from xy to some unknown plane. Let us see. This time the question is given as change the integral, double integral over r, x plus y whole square, x plus y whole square dx dy, where r is the region bounded by the points 1, 0, 3, 1, 2, 2, and 0, 1. Now I'm not talking about polar coordinate. What I'm talking xy to some other plane. This is the integral. Question is saying change it into UV variable such that they are saying that u is equals to x plus y and v is equals to x minus 2y. This is the question. That is, we are having integral in xy coordinate and we need to change it into what? UV plane. By using this substitution, what is r? R is the region in xy plane, students, formed with these 4 points. That is, we need to find the integral by changing this region by using these transformation or these substitution. So obviously, the first thing we need to draw the region. Then the second thing, we have to replace x and y in terms of u and b. X and y is not given in terms of u and b. So the first thing we should do, find x and y by solving these two equations. If I subtract these two equations, what I will get? So if I am subtracting, x got cancelled, y is equals to 1 upon 3 into u minus v. This will be the substitution for y. Now substitution for x. So I should multiply this equation by 2 and add them. So this will be what? 2u and plus b. So x will be what? X will be, it will be 2 plus 1, 3x, that is 2u plus v over 3. I just evaluated x and y from the given transformation to reduce it into new set of variable x, y. Now, moreover, for changing this set of variable x, y to ub, I also need the value of Jacobian. Let us find it. So what will be the Jacobian over here? Jacobian, that is partial derivative of existing variable with respect to the partial derivative of new variable, that is xy with respect to u and v. Put these value and it will be what? Del x upon del u. Del x upon del u will be 1 upon 3. Del x upon del v. No, del x upon del u. This is the x, na? So it will be 2 upon 3, not 1 upon 3. Del x upon del v will be 1 upon 3. Del y upon del u, so 1 upon 3. And del y upon del v will be minus 1 upon 3. I'm just using the concept that we have just discussed in previous and find the Jacobian. Just expand the determinant. So this will be minus 2 upon 9 minus 1 upon 9. So this will be minus 3 upon 9, which will be minus 1 upon 3. It means what? The magnitude of Jacobian that we should take inside the integral will be 1 upon 3. This will be 1 upon 3. So till now we have done two things. One, we have find the new set of variable x and y. Another, we have find the value of Jacobian. Now let us see how the integral will change. So the given integral which is what? Given as double integral over r x plus y square into dx dy will convert it into what? Double integral over r dash. X, we just find what the value of x we are getting, 2u plus v upon 3, plus the value of y that we are getting is u minus v upon 3 whole square into Jacobian into du dv. So it will be double integral over r dash. So if I take the LCM, this is as 1 upon 3. It will be 2u plus v plus u minus v upon 3 whole square. Jacobian we are getting 1 upon 3 into du dv. So we got cancelled. This will be 2 plus 1 3. 3u upon 3, that is only u. And this is square. So I am getting u square 1 upon 3. I am this one taking outside r dash u square du dv. Now the variables are changed, but is still limit of integration we didn't evaluate it till now. So we need to evaluate the limit of integration also with the help of the given reason. As in starting, I have told you that by changing of variable means what? We are changing the reason of integration also. Let us see. The original reason is given bounded by the point what? 1, 0, 3, 1, 2, 2 and 0, 1. This is the original reason which will formulated for xy plane. Let us see how it will look like. 1, 0 is on y-axis, obviously. 3, 1, 2 or 0, 1 firstly on y-axis. This is x-axis, this is y-axis. 2, 2. So this is 1, let it be, this is 2, this is 3. Same over here, 2 and this is 3. 3, 1 will lie somewhat over here. 3, 1. 2 comma 2. So 1 2 1 2 like this. Somewhat over here 2 comma 2 will lies. Just join these points. If I join these points, this is the reason, students, that I obtained, and this is the reason R. This is what? This is the reason R. Now I need to transform this reason into UV plane. Let us see how it will look like in UV plane. So let it be, this is U axis, this is V axis. What the transformation is given to us? The transformation is given to us U equals to X plus Y and V is equals to X minus 2Y. Let us transform this. Firstly, I am talking about the point 1 comma 0. So if I am putting X equal to 1, Y equal to 0, what I will get? U equal to 1. And what I will get? V equals to 1. So the point will be what? 1 comma 1 with respect to 1 comma 0. Moving to the second point, 3 comma 1. So 3 comma 1 will look like X is 3, Y is 1. So U will be 4 and V will be 3 minus 2, that is 1. So point will be 4 comma 1. The third point, which is 2 comma 2. So U will be 4, B will be how much? 2 minus 4. So minus 2. So 4 comma minus 2. On the same manner, the last point that we are having is 0 comma 1. So this U is 1 and V is how much? Minus 2. So 1 comma minus 2. So what I did, first thing, students, in order to evaluate the new reason R dash, I just transform the given point from XY plane to UV plane. From XY plane to UV plane, and this is what they will look like. So the reason formulated by these points will be the reason in UV plane, that is R dash. Let us see 1 comma 1. So 1 comma 1 will be, it's better to draw on the next page. The points I am getting is 1 1 4 1 1 1 4 1 4 minus 2 4 minus 2 and 1 minus 2. Just put these points over here. Let us see what will happen. This is U axis, this is V axis. So the first point is, let us draw the points 1, 2, 3, 4. On Y axis, we are having 1, 2, 1, 2. This is V axis. 1 comma 1 will like over here. The point is 1 comma 1. 4 comma 1 will be over here. 4 comma minus 2. That is on the image of this point along U axis. 1 comma minus 2 will be over here. Join these points. Join these points. And I obtained this reason. That is, this is R dash. This is what, students? This is, we are having R dash. The original shape R is a kind of, we can say, a rectangular shape, not exactly, almost, is converted as exactly a rectangle. Or we can say it's a square, because this distance is 3 and this is also 3, converted into a square. So by the given transformation, the reason of integration is change. Now, the last thing, we need to find the limits. I am taking I strip parallel to V axis for finding the limits. We have done in the previous lecture that how we can find limits from a region. I'm using the same concept. This is the line V equals to minus 2 and this is the line V equal to plus 1. So the limit of V will be what? V will be minus 2 to 1 and U, this point is what? 1 comma 0. This point is what? 4 comma 0. So the limit of u will be 1 to 4. So now this is the change of variable from original xy to uv plane. That is the integral which is look like this. The integral which is look like this. What I need to do one only just put the limit over here. So if I put limit, it will be look like what? 1 upon 3 over r dash. The limit I am getting v as -2 to +1, u as 1 to 4. Inside u square du dv. Now we can solve the integral. Firstly, we should write it dv du because the latest limit we are taking for v na, this one, and in the reverse order perform the integral and we will get the value of the given integral. So now you can see the xy plane, xy integral is converted from xy to uv, which is look like this. I hope you understood the concept. This is how, students, we can find or we can do the change of order of integration. So once again, I'm summarizing that what we have did for changing the order of integration, not order, changing the variable of integration means what? We have to change the reason of integration. We have to change the reason of integration. We have done one question for polar coordinate where Jacobian is directly r. But if there is any other plane or other variable in which we need to change the integral, we have to find the Jacobian. So this is how we can do the change of variable in the double integral. Hope you understood the concept. And that's all from my side, students. Thank you. Thank you very much for your attention.